Here's an application of the intermediate value theorem again. This is on the test. You do need to meet these conditions. I do need to see each one of these points for you to be able to get credit. On WebAssign, it's very easy to get credit or to get the answer right on WebAssign. It's just asking you to find an x value, really. But I need to see you apply the intermediate value theorem. Again, remember the first step to do is to state that it's continuous on the closed interval. The second step to do is find your y values and determine if the given point is between them. And then after that, you actually find the value for x. So let me show you how to do that. It says use the intermediate value theorem to show that the polynomial function x cubed plus 2x minus 1 has a 0 on the interval 0, 1. So again, what's a 0? A 0 means your y value equals 0. This is x cubed plus 2x minus 1. If this were a quadratic, we'd be able to factor it and actually find the zeros. But this isn't a quadratic. This is a cubic. It's a third degree, so we don't know where it's equal to 0. You might remember from your college algebra course, you could use the rational zeros theorem, list all possible rational zeros. You could graph it and find the zeros. But that's not what this problem is about. What this problem is just tell me that it has to cross the x-axis. Has to create a 0, has to have an x-intercept between the x values of 0 and 1. And the intermediate value theorem tells us that this must be true, and let's see why. The first thing is we have to look at our function. X cubed plus 2x minus 1 is a polynomial function. And because it's a polynomial function, I'm going to say thus, it is continuous on the closed interval, bracket 0, 1, bracket. Polynomial functions are continuous everywhere, but what I care about is that it's continuous on the closed interval. That's the first thing we need to do. The second thing we need to do is we need to evaluate the function at the endpoints. So let's use the first endpoint, which would be f of 0. That'd be 0 cubed plus 2 times 0 minus 1. Well, that's a negative 1, right? Now let's plug in f of 1, which equals 1 cubed plus 2 times 1 minus 1. 1 cubed is 1, plus 2 is 3. 3 minus 1 would be the value of 2. So what we're looking at here is we have an x value of 1, an x value of 0, and an x value of 1. We have a y value of negative 1, so here's the point 0, negative 1. We have a point 1, 2 right here. And the idea is I don't even care what this function looks like, but if it's continuous, remember I can connect those points without lifting my pencil. So at some point in time, I have to cross that x-axis. At some point in time, I have to have an x-intercept, or what this book is calling a 0. I have to cross that x-axis between those 2 points. So that's what step 3 is. Because it's continuous on those closed intervals, and because 0 is between the values negative 1 and 2, so we could say since y equals 0 is between the values negative 1 and 2, the intermediate value theorem states there exists an x equal to c, some value c, right, where, so such that f of c equals 0, where c is in that given interval. And actually, it should be the open interval, 0 to 1. So this is a very, very formal proof. I wouldn't expect yours to be as good as this, but I do expect you to at least meet the 3 criteria. First criteria being that you have to state that it's continuous on the closed interval. Second criteria being find the endpoints. Find the y values of the endpoints, I guess I should say. Third one is say, look, my y value is between those 2 y values. The y value I want is between those 2 y values. and therefore there has to exist a point where there has to exist a point where x equals c in that interval, the 0, 1 interval, where I get the y value I want. Notice I didn't have to choose a y value of 0 here. I could have said there has to be a point where f of x equals 1, okay? Where my y value is 1, because 1 is in that interval as well. So the intermediate value theorem would say there would have to be a value c where my y value is 1, okay? Intermediate value does not find the point, it just says the point exists. In fact, finding where this point exists, we would have to use graphing software. Again, we could use the rational zeros theorem, even though it doesn't look like it's going to be a nice rational zero, but there has to be a point where I cross the x-axis. So that's all the intermediate value theorem is, those 3 parts. State it's continuous on the closed interval, find those endpoints, those y values, state if that y value is between those numbers. The intermediate value theorem says there has to be an x value in that interval where you have that preferred or desired y value.